Welcome to Mechanical Tutorials. I'm going to teach you different techniques in SolidWorks for mechanical engineers. Hi, today I'm going to explain about how to create an enclosure for small PCB. See, this is the PCB and I'm going to show you how to design this enclosure body and enclosure cover. I'm going to focus on these two components, and screws and other standard parts like self-clenching standoffs. I'm going to make a separate playlist for this. So this is the enclosure. So this is what I'm going to create the assembly. I'm going to create this top cover and the bottom body with top down approach. So let's start now. So now I'm going to create enclosure cover and enclosure body for this PCB. So this is the PCB assembly with different types of connectors. So we have to open assembly file. Keep it in float. Since I'm doing in top down approach, we have to constrain with planes. So that it doesn't impact on the consecutive components. Now I will work all the components in main assembly. So now I'm going to create this bottom cover, bottom enclosure body. I will save it as enclosure body. Select the top plane, go to sheet metal module, select the base flange. See here I am taking as 1 mm thickness. See, as a thumb rule, usually we take 1 mm thickness. 1 mm. If the component is very small, we can reduce the thickness, or if component is big, we can increase the thickness. So based on that, we change the gauge value. So initially I am taking 1 mm thickness. Now we have to go to main assembly. We have to assemble the component. So before that, we have to see the self-clinching standoff. This is for supporting the PCB. See here there is a supporting. So these are self-clinching. That means it automatically merges with the sheet metal component. So based on this height, we have to assemble this. So let's measure the height. That is 10 mm, and this portion goes into the sheet metal. So these all standard parts I am going to make separate playlist, so I am not creating these components here. So now it is 10 mm. So in main assembly we have to insert enclosure body, say OK. So it is fixed here. Here we have to go to float and move the component. So if component doesn't move, so usually it has to move. If it doesn't move, we have to go to move component option and we have to move it. Now click this face and this face. Here the distance is 10 mm. See here, one more thing we should be cautious is, in the assembly it is IPS and in component it is MMGS. So we have to change the units. We should be very much careful while designing any component in top-down approach. So now we have to go to units. Now assemble with front plane and planes. So every component should be assembled with planes until unless specific requirement. Now right plane with right plane. Now go to enclosure body and edit the base plane sketch. Keep it in top view. Here I am taking as 3 mm. Say OK. So when it goes to edit mode. When we edit any sketch in assembly, it goes to edit mode. The component which we are editing will be in color and other components will be in transparent. Now what we have to do is we have to go to enclosure body. Go to edge flange. Give it 30. Save the file. If you don't save the file, it impacts on the RAM and system becomes very slow. So go to main assembly. So it is asking for updating, rebuilding. So we have to rebuild it. Now we have to create these cutouts for all the three connectors. So once again we have to go to enclosure body. In top down approach we can't unfold and cut the option, so we have to cut any feature in folded state. So select this face, go to cut extrude, keep it normal, take any simple circle and say OK. Now let's go to the main assembly. Now edit this cut extrude. Delete this. Take offset entity and select this. One mm. Sorry. One mm. Go to trim option. So similarly we have to take for this connector also. So 1 mm. Instead of this we can select this, take offset, select this. Since it is a loop, it selects. If it is not a loop like other connector, so We cannot continuously select these lines. Say OK. So here since it is very small, we can take straight away rectangular cutout. Here I am not showing the dimensions. We can dimension according to our requirement. This one we can constrain it. So I'm selecting the OK now. Now keep it in solid form. This is done. Now let's go to the tabs, ears or tabs, we can say. Go to sheet metal, edge flange, see before creating we have to see that top face should merge with this edge, so it is in same line. Now we have to go to sketch. Keep it in top view. Now dimension this. Let me keep 10 mm. See, dimension constraints are very much important in top-down approach. Otherwise, dependent components shows the errors. So let me keep 10 mm here. Here also 10 mm. Let's go to the assembly. So it is in edit mode. So we have to see here whether there is any interference or not. So there is no interference here. Once again we have to go to the art. Now we have to mirror this feature. So mirror about front plane. Select these two. Once again we have to mirror about right plane. and we have to create holes for assembly. Select this top face, go to sheet metal and select simple hole. Take 5 mm. We can take less diameter also, but at this moment I am taking 5 mm. So edit sketch. Keep it 3.5. We can give the dimension, or else we can constrain with midpoint dimension. The center point and midpoint. So we can constrain it. Now we have to mirror this feature. Sketch. So to make sure that it is horizontal, vertical. So select this now. Go to mirror entities. Select this. Say OK. Now once again select this and other circle. Go to mirror entities. So based on that requirement, we have to see whether we have to mirror the sketch or mirror the feature. Now let's go to the assembly. So this small tab feature is pending. I am going to create after this cover is created. Exit edit mode. Save this file. Creating top cover. New file. Save this file to top cover. Select the top plane. Go to sketch. Create one rectangle. And go to sheet metal, base flange. So thickness is 1 mm. Say OK. In main assembly we have to insert this top cover. Select this face, and this face. Front plane with front plane. Say OK, and right plane with right plane. Say OK. Save this file. Now we have to edit this sketch. We are going to edit mode. See here it goes to edit mode and other components become transparent. Keep it in top view. Select this end to end. So automatically it merges with the other component. See here. Now we have to add these flanges. We have to go to top cover, select edge flange, select both the edges. Say OK. Keep it in right view. So now here we have to verify that this edge is collinear with outer edge. Otherwise everything we have to calculate manually. It takes a lot of time. Now let's go to main assembly. Here either we can measure these values, these two values, or we can go to edit sketch. So 3 mm difference. So go to edit flange, so 31. We have to see whether it's merging exactly or not. Or else we can keep it in right side view and we have to see. See here we can see it is merging with this component. So what we have to do is we have to go to edit flange, keep it in right side view, so it is, we are getting exact value. So we have to take material outside. See, there is an interference at this location, rectangular shape you can see. So for that what we have to do is come out of the edit mode. We have to see the radius, 2 mm radius. So go to enclosure body, here we have to go for break corners, fillets, select this edge and keep it 2 mm. Say okay. So save this file. So it's showing a top cover rebuild error. So let's go to sketch. Because since we have given fillet, now it is not taking coincidence. So we have to remove this, click on this point, it shows dangling, take out this and once again. So these kind of errors are common in reverse engineering and top down approach. Say okay. Keep it in isometric. So now we have to create one tab in this cutout. So I am going to explain why we have to create that. Go to bottom component, select this face, go to sketch, keep it normal, select corner rectangle, and take center line, select these two entities and make it linear, and select this point and select this line, take midpoint, select this horizon and make it vertical. So it is exactly at the center. Now keep it 30 mm. And this is 1 mm. This is according to thickness. Now select this rectangle, go to mirror entities, select this center line. Say OK. And go to sheet metal and base tab. Say OK. So here two tabs are created now. Now let's go to main assembly. Here we have to take out this interference, this tab feature and top cover. Go to top component, go to sketch and select one rectangle. Select this line, midpoint and origin. Make it vertical. Select this line and edge. Make it collinear. One mm. So this is 30. So we can give 31. Slight clearance or 30.5. Now we have to go to cut extrude. Don't link to thickness since we want both sides through all. Save this file. Go to main assembly. We have given slight clearance to this. Now we have to see the outer radius, that is 3 mm. So here also we have to create 3 mm at this edge. Now let's go to top cover. Select fillet option and use 3 mm and select all the corners. Say OK. Now we have to create holes for these fasteners. So once again we have to go to the top cover. Select simple hole. Say OK. Keep it normal. Convert entity. Say OK. Exit edit mode. So these holes are exactly created. I'll show you the cross section. See here, exactly created. Now I am assembling standard components. Select this top face, and PCB bottom face. Make it coincidence. Select this whole surface and this hole. Say OK. So these two are sufficient. It is assembled here. Now for other 4 components, go to copy mates. Say OK. Now this coincidence is common for everything, every component. Here I need to select this hole. So it is added now. Say OK. So I don't have to give the meeting. It repeats for every component. This option is good for standard components. So OK. So these are assembled now. Unhide top cover, or show this top cover. Insert screws. See here I have taken M5 screw. We can select any screw wanted. Select this face. Select top cover. Say OK. So it is in other direction. So we have to modify in the meeting. So here we have to flip direction. Say OK. So coincidence we can repeat it. Concentric we can select this face. Say OK. Next, create new exploded view. Here we have to select these four. See animation. So this is the PCB enclosure design. That's how we do it in top-down approach. Thank you very much.